What happened in the universe after the Big Bang? When the universe was first born, it was dense and hot. In these cramped and heated conditions, particles of light and matter were rushing around, continuously running into each other. No atoms could form, because matter particles were traveling too fast to stay together. But as the universe expanded, it became less dense and it cooled. The particles slowed down. Soon, it was cool enough for protons and neutrons to glue themselves together and combine into these small units called nuclei. But electrons couldn't gather onto those nuclei because they were relentlessly smashed aside by powerful photons. This made the nuclei ionized. They had protons, which are positively charged, but no negatively charged electrons to balance out their charge and make them neutral. Meanwhile, the photons couldn't go very far without crashing into electrons and newly formed nuclei. The photons bounced around like sunlight does in a dense fog. Because all the light was scattered around, the entire universe was foggy. But as time passed, the universe continued to expand and cool, and it became much less dense. With more space between them, photons and electrons collided less often. Electrons began joining with nuclei to form neutral atoms. And now, with the electrons out of the photons' way, the path was clear for light's great escape. 378,000 years after the Big Bang, the fog finally lifted. No matter how big or powerful our telescopes become, the cosmic microwave background is the oldest light we will ever be able to see.